Hello and welcome to the webinar with the topic Modbus RTU KNX Gateway MGS. My name is Jürgen Schilder from the ABB Building Academy Smart Buildings. In this webinar I will introduce you the new Modbus KNX Gateway. The gateway enables an easy and quick integration of Modbus devices such as ABB EQ meters into a KNX installation. The webinar lasts about an hour. The session will be recorded and published on our training and qualification database and on YouTube. What's on the agenda for today? I would like to start with a product overview first. This is followed by the installation and commissioning with the ETS parameters and the device configuration app DCA. Before I come to a practical demonstration, I will show you an example how to put an ABB EQ meter and a Terra AC Wallbox into operation with the gateway. So at first, let's have a look on today's situation. Now Modbus RTU is found in multiple devices and in a wide variety of applications like for metering, HVAC, EV charging or also for room control. And so it is common to find Modbus devices in the same project and installation where also KNX is installed. And with the new Modbus RTU KNX Twisted Pair Gateway, it allows to integrate these Modbus devices into a KNX installation quickly and easily at the field level. So not on IP, we are here on KNX Twisted Pair and on Modbus RTU. So what is Modbus RTU? Modbus RTU stands for Remote Terminal Unit, and it's a serial communication protocol which was developed for PLC, for programming logic controllers, some years ago. And it's a communication method for the transmission of information via a serial cable between devices. Similar like our KNX cable. So we can use also for Modbus RTU in principle the same cable type like KNX. And now Modbus has become a de facto standard communication protocol. It is not a real standard, it's a de facto standard. Later you will see also why. So the devices in the Modbus world which request information or pulse information are called so-called clients. So this is one important name. And the devices which send information to this client are called servers. So these are devices which respond. And in a standard Modbus RTU network, we have only one client, and we can have several servers. So, and the cable topology of a Modbus RTU is a purely line structures, like you can see it on the right side. So we have on the right side one client and several servers. So more information about Modbus are available online, so you can Google or you go to modbus.org. Furthermore, there is also a system called Modbus TCP, but this is based on Ethernet, on IP. So it is used, for example, by our QoS energy analyzer to forward our data's metering values to a higher level, like, for example, to a SCADA system. So, and another communication protocol is MBus. MBus is another system. So please don't mix it up here with Modbus. Here we talk about Modbus RTU. So on the right side you can see here our new gateway. You see on the left side we have our typical KNX installation, and on the right side we have here Modbus RTU. So our gateway is the client, and via this client we can integrate Modbus devices, or so-called also servers, via a standard RS485 into our KNX system. So in this way, the KNX system perceives the entire Modbus installation with all the meters and the devices as if it were another KNX device of our system. It is similar like our DALI gateway. Via the DALI gateway, we integrate the DALI technology with all the electronic ballast also here into our KNX installation. And the same we have here with our Modbus RTU gateway. So the gateway is a modular DIN rail device, so it can install it on a standard rail in the distribution board. The Modbus KNX gateway is a bidirectional gateway, so we can send information from the KNX world into our Modbus world and also vice versa. Maximum we have here about 100 freely configurable data points. So 100 write and also receive commands. So for this purpose, the gateway continuously polls or sends requests to our Modbus devices, like for example our meters, and assign the answer to our KNX group object via the so-called Modbus data point mappings. This is what we have to do to convert our meter values from, or our Modbus values here, into our KNX data points. Furthermore, we can send commands from KNX into our Modbus world. Like for example in the room, we have a KNX room temperature controller and a Modbus fan coil controller. So we can send our control value from the room via KNX to our fan coil controller in the Modbus world. So, and this mapping between our Modbus data and KNX data points happens via so-called mapping templates. So we have some mapping templates for some devices, and this helps us really for quickly integration of the gateway into our KNX world. So now let's come to an overview of a typical system overview with our gateway. In the middle we have here our KNX Modbus gateway. On the left side we have our KNX world with our switch actuator, which can be used for example for load control, a smart touch which can display our meter values, the energy analyzer for more energy management, and for example like here a room temperature controller which measures the temperature, and depending on set point he sends the control value into the Modbus world and controls, for example here, a Daikin interface for VRV or for inverter chillers or also for fan coil controllers. So this is one direction, and the other direction is that we get here the meter values, for example from a Terra AC Wallbox or from an ABB energy meter, M4M, room control unit. This is the other way that this device, for example, send here information control value from Modbus into our KNX world when we have our fan coil controller here connected to KNX, our typical climber echo devices. So you see we have a lot of possibilities to send information or control devices from KNX to Modbus and get a status here also vice versa. So do not forget we have here our wording. Our gateway is the client, our so-called level converter, and we have here on the right side now Modbus world only server devices which answer here to the request or the polling from our client. So then let's come to a, let me say, possibility to a slide which gives us more information about integration of metering. Left side you see our existing solution with our KNX meter interface ZSS. So the meter interface receives the data via an infrared interface from our energy meters of the A and B series and send it then to KNX. And with this existing solution, we need per meter a meter interface ZSS. But this can be a standard meter without communication. This is not an M-bus or Modbus. This is a standard meter, no communication interface. This is our existing solution, like here, 1 meter interface per meter. On the right side, you can see the new solution with our Modbus KNX Gateway MGS. So it is a bidirectional gateway which works in both directions, and we have here 100 freely configurable data points. So we can write, we can read or read-write. So with this one we can connect several meters or analyzer or other Modbus device, and we need only one gateway. But this device here works only for Modbus RTU devices, not here for M-bus or for other systems. So at the moment we have then now 2 solutions, our still existing meter interface ZSS, and on the right side our new one with the Modbus RTU gateway. So then let's come to the product overview. You see here on the right side the pictures. It is a standard modular DIN rail installation device which can be mounted in a standard cabinet or distribution board with 35mm mounting rail. So the device is only powered via KNX and requires no additional auxiliary voltage. But the device can use up to 22 milliamps from KNX. So when you plan an installation and calculate the number of devices, please be careful, it counts as 2 devices because maximum 22 millimeters. So in principle it is a standard KNX device with our KNX bus connection terminal and a typical programming button and our LED. So the one and only tool to commission, to download a KNX device is the ETS. So we need here the ETS 5 or ET6 for linking the group addresses, for parameterization, and so on. So to facilitate the configuration, it is recommended to install here or to use the so-called device configuration app, DCA, which is free of charge. And with this device configuration app, we can create also our own mappings. When you have, for example, third-party devices and there's no template existing, then you can create your own mappings. You can export it, and we can also import mappings of some meters like B meters, A meters, yeah, or also, for example, the Terra AC Wallbox. But this will I show you later in some more slides. So the device, the official description is Modbus RTU KNX TP Twisted Pair Gateway 100 points. The type MGS 11. 11 stands here for Modbus RTU 100 data points, 11, and the ordering number. So when you order the device, it comes in a box with the hardware, with the device, with the individual address like a standard KNX device 15.15.255. Including the installation and the operating instructions, like you see here, the datasheet on the right side. So some more technical data. The connections to Modbus is via our protocol RS485. It's a 3-pole terminal block to KNX, our standard connection terminal. The dimensions you see here, 92 millimeters, to 36. So we have total here a module width of 2 units. So the only thing which you have to be careful is that it needs maximum 20 milliamps, so it counts as 2 devices in a line. So on this slide you can see the connection diagram. So we have our KNX Modbus gateway connected here to standard KNX via our KNX bus cable, and the wiring here of Modbus RTU. Modbus RTU, we have the 2 data lines, A and B, and one common, the C, or here also the ground. So, and all devices, our so-called Modbus server, are connected here to the A and B and the C. According to the RS485 standard, we need so-called end-of-line resistors at the beginning of the line and at the end of the line. This is principal technique of Modbus RTU. So, and when you have a look on the device, we have our labeling field. Labeling field is here to write the individual address of the device. We have new here a 2D code. Later I explain you what is the 2D code. Then we have our KNX programming button. We have here some dip switches for some settings, which I show you in the next slide. And we have here our RS5 Modbus connection. So Modbus is only a de facto standard. That's why I have here very important written a note. So with some devices, the data lines A and B must be swapped, like in our ABB EQ meters from the A and B series. So if there are communication problems and a device does not respond, so please swap the data line A and B at this device. So then we come here to our operating controls and the display elements. So here on top of the device you can see the KNX programming button, the programming LED, it's here SMD LED, which is our typical LED when the device is in the programming board, when he expects a new individual address. Then we have here a dip switch. The dip switch, we have 3 switches. With the first switch we can activate or deactivate the internal 120 ohm termination resistor. So when the device is at the beginning of our installation, you can use here the internal end-of-line resistor. And with the second and the third dip switch, we can activate or deactivate the polarization. This is also here a feature of Modbus, that at one point of a Modbus installation, there must be a polarization. So you can do it also here when we set here the parameters to on or the dip switches to on, which is also as default. So then we have here a LED, which is a so-called Modbus LED, and the Modbus LED is off if there's no KNX bus voltage available and the device is not ready for operation. The LED is on if it's connected to KNX and without communication, like for example the device is unloaded or no Modbus device was here configured. So the LED is low flashing if there's an invalid response or no response from a Modbus device. And if everything is okay, all Modbus devices respond, then we have here a fast flashing, and this should be then the normal state. So all meters or all devices are configured and have a valid communication here to our Modbus gateway. So then let's come to a connection diagram with our Modbus gateway here on the left side. Remember, at the beginning and the end, we need an end-of-line resistor, so-called or termination resistor of 120 ohms. This is here a system of Modbus or RS485. So when you use the internal dip switch number 1 and you set it to the position on, then the internal 120 ohm terminating resistor is activated. So this is okay here for the beginning of the line. And then we go with the cable to the next meter, next meter, next meter, and so on here in a purely line structure. And at the end, we have here additional a 120 ohm resistor for the end. So this end of line resistor at the beginning and the end of our cable is required to prevent the reflections. So when we have a cable and there happens reflections at the beginning and the end, so that's why we need here two 120 ohm resistors. Yeah, and in the middle we have here our Modbus devices, like for example ABB energy meter. So remember, some meters of some devices you must swap here the data line A and B. When you have here, look, we have here the communication. Here you can connect the cable, the Modbus cable, here with CBA, but it's this device here you must swap A and B. That's why we come here with our data line C, go to the next device, but A and B must here swapped in our meter. The Terra AC Wallbox here on the right side is not necessary to swap. You go here in with A, B, C. You see here, this is a screenshot of the Modbus Terra AC Wallbox. We have here A, B, C, and you see also here the description on the wallbox. So in the middle you can have here, of course, more Modbus RTU devices. How many? It depends how many data points we use per device. So total, we have here a KNX interface which have maximum 205 communication objects, or so-called group objects. 100 are for status, 100 are for control group objects to send commands from KNX into our Modbus world. Then we have 4 error status group objects, I'll show you also later, and we have 1 optional group object for in operation. So the device can cyclically send here a live signal to KNX. So then let's have a look on Modbus. We can have here Modbus address range from 1 to 254. So in Modbus, each Modbus device needs a unique address between 1 and 254, which must be set in the Modbus device. So here we have a range from 1 to 254. So total we have data points, maximum 100. It can be a read, a write, or read-write, which can be used, for example, to send a command and read back automatically then the status. So the maximum number of supported devices is of course is here maximum 100. So but the real maximum number of supported devices depends on our data points. Remember, we have maximum 100 here of these data points. So on the right side you can see here example. I have here several Modbus devices, like here one has the address number 1. And in the device number 1, we have here on my example, I used 12 data points here for reading, no for write, but for read-write 2. So I have here in my Modbus device with the address number 1 used 14 of these data points. Modbus number 2, I have used 17. Then I can make also gaps. It's not necessary to have address 1, 2, 3, 4. I can make gaps. For example, this is a device in another room, another floor, which has an address number 21. Here I have used 20 write data points, 5 read-write, 25, and here my device number 78, for example 20, and another Modbus device here with 7. So total I have used here 83 of these data points. So I can use more Modbus devices, but the maximum number of data points are here limited to 17, because these 83 which I used plus 17 equals my maximum number of 100 data point types. Good, then let's come to the installation. The device is a standard DIN rail component which can be installed in a distribution board or on a cabinet on a 35mm mounting rail. 35mm mounting rail means here this is our mounting rail. This here we have 35mm. You place it on the rail and press down, and via screwdriver here, for example, Yeah, you can pull here the lower latching level and then fix it on the device. In the same way, you can also release the device like a standard KNX device, you know. Good, then let's come to the commissioning. So at first we need our ETS software, and the software we use is our ETS engineering tool software. We need minimum the ETS 5 version 5.7.7 or today the ETS 6 or of course higher. So then we need the ETS application, the so-called KNX profile. You can download it from our website abb.com/knx and then go to System, Infrastructure and Interfacing. This is here the chapter of this gateway. So here on the right side you can see exactly our website, and then when you scroll down, then we come to software, and then you see here the ETS application KNX profile, and then you can download it. So, and it's also recommended to use the so-called device configuration app. This is additional software for the ETS. It is free of charge, and we can use it, for example, to import our device templates or also to export to create our own templates for Modbus devices. So you can download this DCA app also here from our website. You see software ETS app, template configuration ETS app. Of course, it is free of charge. Or you go to the KNX online shop, myknx.org, you log in with your account, and then you can also download here for free of charge this app. So, next step, that all our Modbus devices are connected to Modbus according to the wiring, configured. So you have to go to the Modbus devices, set the speed, the address, unique address, so each Modbus device must have several addresses, and of course parity. Yeah, and some more start-stop it. So this must be done. So all Modbus devices must be ready and installed. When you use the KNX interface, which supports so-called long frames, like our USB interface, UBS 1.2, or the IP router or IP interface 351, it can significantly shorten the download time because this interface uses for download a KNX long frame mechanism. So and then the download is faster. Good, okay, this is done. We have the ETS, we have the KNX plot file imported, we have installed the ETS app, Modbus devices are ready for operation, USB interface, and then we can start. Some words about this ETS device configuration app, DCA. When you have downloaded, then you have to go to the ETS 5 or 6, and then you have to install it. So we go to the settings of the ETS, to the submenu ETS apps, and then click here on the button Install App, and then the app is installed with other apps, like for example we have here used for ABB, like the app for the split unit gateway or our firmware update tool or for the application controller. So this app is not necessary but highly recommended because we can use here the feature of the import of the mapping for our KNX data points. And additionally with the app we can make also a firmware update of the Modbus gateway. So then we start in the ETS like always. We add the device from the catalog into our project. We set at first the parameters for general for KNX. Like for example, we can activate the in operation telegram. Then we set the parameters for Modbus, and then we set the parameter per Modbus device, per Modbus server. So we can also use our so-called templates for the mapping between KNX and database. Or if you don't want, if the mapping is not existing, the template, then we have to do it manually. So then we link the group addresses to our group objects. We download the individual address, download the ETS application, and now we are finished. And at the end, if you want, you can also create and export your self-created device templates for your own devices or third-party devices. So then let's do it here step by step. So let's go to the catalog. Here on the right side you can see a screenshot of the ETS catalog. So you can import the device from the catalog when you go here to ABB, System and Infrastructure and Interfaces, and in the subfolder Gateways, there we will find our Modbus RTU gateway. Or you go here to the filter and you enter here MGS, and you see here then immediately the gateway independent where you are here on the left side and the catalog. So then import the device into your project. So then we have here at first our so-called main page, our general page, general parameter window. of our Modbus RTU. You see here, we are here in the window parameter, and here we can see our second window for DCA, which I'll show you later. So then click here on the first field here on the general. Then on the right side, we can see then some general parameters for the gateway, like for example at the moment the total gateway data points. Here you can see the number between 0 and maximum 100 data point types. Also how many we have parameterized here in our Modbus devices. So then we have in the next section we have here the settings which can be made for KNX, and in the third here for Modbus. So here let's have a look here on the KNX settings. Here we have a parameter so-called read on init delay. Here we can enter time between 0 and 255. This is the sending delay of a group value write telegram for a group object with an initialization flag I. So what does it mean? If the device makes a restart, maybe there was some KNX failure in the line, and then when the initialization flag is set on a communication object, he sent a group value read telegram to other KNX devices to read out the status and to get back a group value write answer telegram. So then we have here a time telegram rate. This is the waiting time between two telegrams which are sent on KNX. So here with this parameter we can limit our KNX bus load or the bus traffic. And in operation, when we activate it, then a new parameter pops up where we can send the cycle time to send here a live signal between 1 and 255 minutes to monitor device with another KNX device, or like for example visualization or another device. So then we come here in the third section to our Modbus parameters. So at first we have to set here the baud rate of our Modbus, the transmission speed. So default we have here 9600. And in our complete Modbus system, all devices must have the same baud rate. So you cannot mix meters or devices with different baud rate. So when you set here 9600, like here in my example, then all Modbus devices must be set to a baud rate of 9600. So here we have a range between 1200 and 115,000 bits per second. So the next we have our data type, the data byte. Here we can specify, for example, the none or even or bit parity or the start and the stop bit. So these parameters must be all the same for all devices in the Modbus system. So this is also very important when you set here, like, for example, like a parity, even or odd. This must be the same in all devices. So then we come to our response time. The response timeout time. This is how many milliseconds the gateway waits between sending a request to a server into our Modbus world and receiving a response. So between sending and receiving, this is here our time. So, and if the gateway does not receive a response, it resends the request again. And the gateway repeats the request 3 times before reporting the error via our via corresponding error status group object to KNX. So default you can keep it like it is. For example, this 1000 milliseconds, but some server have a long processing time. So please read the manual of these Modbus devices and see if you have maybe to extend the value to 2 seconds or something. So then we come here to interframe timeout. The interframe timeout is how many milliseconds the gateway between receiving a telegram from Modbus and sending the next telegram into our Modbus installation. So with this parameter we can limit it the Modbus traffic or the Modbus load. So then we have here poll after, right? This is a parameter when we activate it and send a command from KNX into Modbus, then the gateway immediately polls the status. So he's not waiting until he comes to the status object, he polls it immediately after writing a telegram. And the number of devices, here we can add more devices. As default we have here 1 device, and then you can say 2, 3 or more devices. Then it appears here in the list of our devices. At the moment I have here 1 device. Then you see here the name of the device, device number 1. You can change it like you want to the name of your Modbus device, like meter B21 in the 3rd floor or something. We can change here the server address between 1 and 254. We can here add the number and give the number of many data points we have, and here we can activate the device, and then it is integrated by the gateway and he pulls or sends commands to the device. So far, these are the general parameters. So then we come to the parameters of the individual devices. So for example here, my device number 1, like as default. Then I come to the settings of this device here. Here again, you can change the name, or you can do it in a general parameter window. We see here the server address between 1 and 254, the number of data points, and the device now is active. So here we have the number of data points between 0 and 100, and if you activate it, then the device will be also integrated and will be pulled with the data points. So then we come to the, sorry, I for the wrong button, so this way. So then we come here to the settings, the KNX settings of our device, like here my device number 1. At first, we have here a checkbox to activate a single object. This checkbox belongs here per my object number 1. So if I want, for example, disable it, then I can deactivate it here. So then we come here to the so-called number. This is number 1, number 2, number 3. This is the information or the number from 1 to 100. This is the same later in our KNX group objects. The object name, here we can enter a name, maximum 64 characters. What is it? It's a voltage, a frequency, or so on, if you manually configured. Then we come here to our data point types. We have here data point types, typically 2 byte or also 4 byte, which can be selected here manually. If you are not sure about these data point types, you can click here on this link. You will get it also in the email. Then we'll get here a guidance from the KNX Association, which explains all these KNX data point types. So then we come to this is maybe more on the right side when we move a little bit here the window. Then we come here to our settings for Modbus. At first we have here the server address, which is still 1 because we have set it here to 1. Then we can enter here the read function. So we have different codes in the Modbus world. Like for example, we can read coils, we can read registers, holding registers, and so on. So this is what we can set here if we want to read something. For write, we have here the next parameter. Here we can write values or commands from KNX into the Modbus world. And here we can, at next slide, then we can specify also here the data links. So in all this information, if it's read holding register or write single register or so on, you will find it in the product manual of your Modbus device. So you need this documentation from your meter or, for example, to configure here the correct read or write function. So on the next slide we have here then the data lengths, if it's a 1-bit, a 16, a 32 or 64-bit value. This is the value of our Modbus register in our Modbus device. Then the format, for example, if it's an unsigned, signed or float value must be set here. The byte order, if the high or the low byte or the high or the low word first or last, it can be set here via this byte order. And then very important, the register address. The Modbus gateway reads out the register address with the voltage, the current, the power, and this register address must be entered here in decimal. Be careful, in the product manual you get it often in hex, and then you have to convert it from hex into decimal. So then we come here to the bit. This is, for example, if you want to really read a specific bit in a register. Usually it starts with the bit number 0, but here you can specify I want to start with bit number 5, and then I want to read here maybe 2 bits. For special application you can use it. So then we come to an important parameter, our so-called deadband. The deadband defines our KNX sending behavior. So here we can enter a value, the value we specify when the telegram is sent here to our KNX world. Maybe we have a little bit change on Modbus, and then we specify here if it changed more than 0.5 volts, for example, then it sends to KNX. And via this parameter, we can also limit then our traffic on KNX. So it's a little bit tricky. That's why I want to give here a good example. What do you have to enter here in the deadband? So at first, when we calculate here the deadband, because it's a Modbus parameter, we have to look on our Modbus raw data. What it means, the gateway reads out the values from our, for example, meter, a voltage, but the meter provides this value in a register as an integer value. So he cannot read out a float value like we know it in KNX. For example, in the register address, you will see it here on the product manual of the meter, you will see the voltage is on the register address and it comes here with a resolution of 0.5. So this is very important to know this resolution. So what does it mean? In the register, we have a value of 2308, which means 230.8 volts. So, but it's read out with this raw value of 2308. So in our mapping in KNX, we have to multiply it by this resolution, and then we get on KNX 230.8. So, and the same we have to do when we calculate, or when we calculate here our deadband. So, for example, we want to have that on KNX a telegram will be sent if the KNX the voltage changes here of 0.5 volt. So then we have to define a deadband, which is calculated that we can say, okay, our KNX minimum change value is 0.5 divided by the resolution. Remember, the resolution is 0.5. So we have to take this KNX minimum change value 0.5 divided by our resolution from 0.1 equals 5. And then we have to enter this value 5 here in the deadband of the Modbus parameter. I know it's a little bit tricky, but this is here our Modbus specification. Good. Then we come here to the next step here, the so-called operation. Operation, we can here define different mathematical operation, for example, like division or multiplication. And we need this operation when we want to convert our Modbus values, which are integer, signed or unsigned, into KNX floating point values. Because on Modbus, we have only integer values. We have no float values. And via this operation, then we can divide, we can do RMS, we can do some calculation like multiplication or division to convert this Modbus raw data into KNX floating values. So, and how it works, I show you here again on this slide. So what we need is our product manual of our meter, like for example here, our B21 meter. We have here our voltage and the resolution again. You see here, the value comes with a resolution of 0.1. So in our Modbus register, we have the value of 2308. So what we have to do, we need a new calculation that we say, okay, operation divide this Modbus raw value of 2308 divided by 10. This is divided by the inverse resolution. The resolution is 0.1. And the inverse resolution is then 10. So you can say here, okay, I take my value of 2308 and divide it by 10, and then I have on KNX 230.8 volts. You can select divide by 10 or multiply by 0.1. It doesn't matter what you prefer. So this is a parameter which is very important when you have, for example, here wrong decimals on KNX. If you get on KNX 2308 volts, then maybe you have forgotten here to select here the correct operation and divide the Modbus raw data with the value 10. Or here the energy comes here with a resolution of 0.01, and then you have to divide it by, for example, 100. Or here the power factor. The power factor comes with a value 0.001, and then you have to divide it by 1000 to get the correct data point or the correct value here in our KNX word. So of course you can do all this mapping here manually, or you use our templates, because in template we have set all this operation and all these values. Good, then let's come to the so-called device configuration app. So here we go here on or not, we leave our parameter window, we go here on DCA, and on DCA, then we have here the parameters, the settings, the settings here in our DCA. So at first what we can do, we can export a mapping when we have created our own mapping. We can import a mapping from our database or from our hard disk, for example, and we can edit here our devices, and we can make here on the last one, we can make here a firmware update. So it's not really recommended, it is not really necessary. It is recommended to use here the DCA because it makes you the life easier. So let's come at first here to the so-called export device templates. So here you can select one of the device, Modbus device, and then you can export the complete mapping with all this multiplication, with all this deadband and all these things. So maybe this is for your own, when you have a third-party meter or third-party Modbus device, you can create your own template, you can export it, and you can use it here also on another project, and you can share it with someone else. This is for export here a template. So for us, when we work with ABB devices like B-meter or here our Terra Wallbox, we have now existing here a so-called template for B23, B24 meters and the Terra AC Wallbox. And more templates, of course, will follow for M4M and other devices. So how to use the templates? I think it's not difficult. You click here on the button, add here a device, then a new window pops up where you can here select, would you like to import a file from the hard disk. You can also download these files maybe from our website and you have it on your hard disk. This is one possibility. Then you select here your meter, B23, or for example your Daikin or what you have, or here the Terra AC Wallbox. You select and you click then on the button import. Or you can import it from our database. So then you must be online. Then you click here on the button download. A new window pops up with the list of all manufacturers, like here for example ABB or Daikin. Then you can select here and import this template here online from the database. And of course more templates will be also available here in our database. So when you have imported from the database or from the template, doesn't matter, the next window which appear is here the list of all these data points, which some of these maybe I think importance are here now still activated. Like for example here the instantaneous voltage between phase L1 neutral, phase L2 neutral, phase L3, the current per phase, the actual power. You see here the correct KNX data point type is here set. Like here for the power, active power, we have the data point type 14056. This is for power. We have here selected the correct function code, read holding registered, the format, and you see here also the register address. This is the register address 23316 to read out the power here in an ABB meter B23 or B24. So you import only this template, and then maybe you can activate or deactivate here some of this data point and click on the button apply. That's all. So then you have done it, you said okay, I use these default settings, click on the button apply, and then you have it in the list. So, and the next possibility is here to add a device, like for example, to replace a device. You select a device and said, I want to replace it. When you click here on the blue button, or here with the red X, you can delete of a device. So, and possibility number 4 here in our DCA app is to make a firmware update. So when you're online, you click on the button Firmware Manager, then a window pops up, and then you can make here a download via the internet from our server, or if you have the firmware update file on your hard disk, then you can import it here, start then the firmware update of one or more devices, and then you will see the update, for example, here is running. So if you have a gateway, then please check if you have the latest firmware installed. Good, so far. And now I would like to give you some examples, the commissioning examples of an ABB Terra AC Wallbox when we use this template, of a B23 meters, also with a template, and a B21, which we have at the moment no template. Then we have to do the mapping manually, or like a third-party device. So this is exactly here what I have in my installation. Later I give you also practical demonstration. Here on the left side we have our KNX devices, then in the middle our Modbus KNX gateway, and via KNX Yeah, we want to send some commands or controls here to our Modbus devices, like for example, yeah, we want to start or stop the charging session of a Terra AC Wallbox. It's also possible. Or to set the maximum charging current here, also possible via KNX. Yeah, or to read out here some meter values. So here, for example, my Wallbox has address number 5, this meter number 1, and this meter here, the address number 2. So then let's start at first how we commissioning the Terra AC Wallbox. At first you have to go to the Terra Wallbox, set here an address via the Terra AC config app, like for example here has the address number 5, and the device must be also set as a secondary device. These are the necessary settings we have to make here in our Modbus device, our Terra AC Wallbox. So okay, then it is also configured with the speed. For example, we need here the speed the same like in our Modbus gateway, the start, stop bits, and so on. So then we go back to our KNX world. We add here the template. You see the template is available online or on our database. Then we import the template in the ETS. Then we can activate or deactivate some of these data points. Yeah, and then the gateway, we create a new device, including the activated data points, including the function codes, the register addresses, and so on. Then we set here our sending behavior, our deadband. Then we link the group addresses and so on. And then we can make a download. And these are the necessary steps we have to do. So this is exactly here our template. So when you add the template online, or for example via the file, then you see here the data point types of this Terra AC Wallbox, like for example the maximum rated settable current. We have an error code, the socket lock state, the charging state, the current charging current limit. This is the maximum current we can, which can be used for charging. The current per phase, the voltage, the active power, and here we have, you see, the commands set charging current limit. You see here it is write information. We write into the register 16640 a value. Like for example the maximum current 10 amps, 8 amps, or 12 amps. These are the commands which can be sent here into the Modbus device in our Terra AC Wallbox. So okay, then you can see we can keep all this as active. You see here at the moment we have 17 of these data point types are active. We click here on the button apply, and in the next step we come here then to our parameters of my Terra AC Wallbox. You see all these values from templates are now here in my parameters. Exactly here the name of the object. This comes all from our template. You have to do nothing. You select only the objects you would like to have, and then you have it here started with 1, 2, blah, 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 up to maximum 100. So here we have again our locket state, charging state, for example. The charging state, this is not a float value, this is a 4-byte value, and on some bits, you have the information if the car is connected or this one or charging and so on. So you see the charging current is set here to 14019. This is the KNX data point type here for our electric current. The byte order is correct, and you see here again the operation that, for example, here our voltage, remember, comes here with the factor 0.1, so you have to multiply it by 0.1, or you divide it by the inverse resolution, which is 10. So this is everything is here done. In principle, you have not to touch it, and then you can start with linking the group objects. So when we have done a look here on our group objects, you can see here D1 is my device number 1, and you see the name is exactly the name we have here in our parameters, like voltage phase 1. You see exactly here status voltage phase 1 and so on. You see the information, it goes here from Modbus to KNX, so it's a status, or it goes here from KNX into Modbus. It is a control or it is a command, and you see here again the data point types, everything here is set. So to link group addresses, download, finished. Very quick and easy solution by using here our templates. So then when we have a look here on the recording via the ETS group monitor, then you see, for example, here on this group object 456, I have the user settable maximum current, 60 amps. This is what I can use maximum here for my Wallbox. Yeah, you see the error code is 0, everything is fine. Yeah, you see here at the moment the maximum charging current limit is limited to 10 amps. Yeah, no current per phase L1, L2, L3 because the car is connected to my Wallbox. Yeah, it's ready to charge, but the charging is not started. So you see here again the power here at the moment it is 0. Yeah, no charging process. Yeah, what I can see also is, for example, here you see the firmware version of my Wallbox. It's 165. So it is here in hex. This is the firmware at the moment in my Terra AC Wallbox, and you can also see here the serial number. Serial number 33 was one of the first Wallbox. Good. So when we start then the recording, when we start then the charging. So via KNX, I send the information from a control element, like here my sensor, here to my Wallbox start charging. So, but here we have not our typical 1-bit information in KNX. 1 is start and 0 stop. No, we have to use here a 2-byte value with the value 0. So the value 0 starts here our charging session. And then you will see after some seconds he goes here, starts charging 38, 1524, 1600. And then you see, for example, then here the power at the moment. You can see the current. And you can see here also the energy delivered, 10 watt hours, and then of course it will increase. So this is exactly the situation when we start charging the car via a KNX telegram. Of course, we can also then change the current, depending maybe on my available energy from my solar system or from my, for example, controller, which is okay. You can use more. Then I can send here a value from my logic, set charging current to 12 amps from KNX into my Modbus world. And then you see in the next step, he responds, yes, I accept the 12 amps, and then you will see he changed it to 9. To 9, and then maybe here 11.2. We have only set the maximum current, but the real current maybe I think depends between the car and the Wallbox. Good, this is how to change the maximum charging current depending on the availability of energy in my building. And the last possibility is here also to stop the charging, like here from a control element, but here I have to send the value 1 in a 2-byte unsigned telegram. So this is for stop, because these are here Modbus commands. Good, and let's come here to a B23 meter. The same principle. We have here also a template. Then we have, I think, exactly to do the same. We add a device. We imported it here from our catalog or from our database. Then you see here also some of these data points are here selected, like for the power, L1, L2, L3, the current, the voltage here between phase and neutral. And here, of course, we have some more. And then you can activate or deactivate it. You see here the register addresses, and so on. When you click on OK, then you get here then the data point types with the correct function code, the data lengths. You see here the energy comes with 64 bits, and here again the operation and the factor. Everything is set here and done. So then the same principle. You link the group addresses. You have here the objects of all these KNX data point types, and then we can start a recording. Like for example here, this is the recording of the B23 meter, a 3-phase meter. You see here the active energy at the moment. We have here the voltage between the phase L1, L2, L3 and the neutral. No amps, no watts, no energy. And here at this moment I send a 1-bit command from a control element to switch on a load. The switch actuator sends the status back, and then you will see the load is on, because here our energy, the total energy goes here to 42 watts, and here we have the energy here per phase L1, and here this is the total. So these are the values then which comes back here from our Modbus meter into our KNX value. Good, then let's come to a device like my B21 meter, and at the moment is not yet available such a template. So we have to do this mapping of the Modbus values and KNX manually. So you will see it is not really difficult. So then we cannot use the DCA app. We have no template. Then we have to go here to our main page, General, and here we go to number of devices. and then we increase it by 1 because I have here my Wallbox, my B23 meter. Then I increase it by 1, and then I get here a new device, device number 3. I can enter here user-friendly name, give my meter our address, like server address number 2, and I would like to have here 6 data points, like for example for energy, for power, voltage, current, frequency, and my power factor. Okay, I want to have here 6, and then I go, it appears here a new device, and I can do then the configuration. So I click here on my new device number which is my B21 meter. I can do also the settings here. I can change the name here, the same like on the page before. And then you will see I get here 6 objects because I set here number of data points 6, and then I get here these 6 objects. As default, object name for KNX and the data point type. So then I need again the product manual of my meter to know on which register address I have my voltage, my current, and the resolution. This is very important. So then I set here, for example, manually the object name. So I write here active energy. The next one is my voltage. The next one is the current. And I set here also the data point types according to KNX. It's, for example, a voltage or a current. Good. To get this information, you need the product manual. And in the product manual, you get, for example, here then of the active energy. The active energy is, for example, has a size here of 4 register addresses, and register addresses has a length of 16 bits. It is unsigned. You see the start register address in the B21 meter, and you see the resolution. So now you have to use this information and enter it here in the Modbus parameters. So at first we have here the data length of 64 because the size here 4 multiplied 16 equals here 64. So the format, we can keep it like it is unsigned. The byte order is big endian. And now we have to convert our register address from hex here into decimal. So we can use the window calculator which is installed on your PC. And the resolution here, it comes with 0.01. So then we have to divide it by the inverse resolution or multiply it with the standard resolution. These are the parameters you have to enter here. The register address, the byte order, the length, the function code, read holding register, and at the end here the operation divided by 100. So this is what you have to do manually per data point. This is here for the energy, and the similar it is for the voltage. The voltage is on the register address 5B00, converted it into decimal. You see the resolution is 0.1. Then you have to divide it by 10 here in the operation. And the register address data links, here we have 2 register addresses, 2 multiplied 16. We have to enter here 32 data links. Read holding register, select here the KNX data point type 14027 electrical voltage, and enter here the name, and the name is also then available in the object. Good, and the same for the current, for the frequency, for the power factor, and so on. So when you have done this, then you get here the 6 objects: active imported energy, voltage, current, and here the information. It is from Modbus to KNX and the correct KNX data point type. So this is the manual configuration. If there is no template available, for example, it's a third-party device, or here like the B21 template, which is at the moment not yet available. So at the end, you can go back to the DCA, and in the DCA you can export exactly this template and use it for your own template, or you share it with someone else, or you use it in other projects. Good, and here the same. Then when you start here the group monitor, the recording, you see then here the energy, you see the voltage, the current, and here at the moment I switched on via KNX Telegram. Then you see here the load. For example, I have here a load of 25 watt. It's the standard incandescence lamps. You see the cosinus phi here, and you see here also then the current of 0.11 amps. Good, so far. Then I would like to give you a short practical demonstration. Time is running, 10 a.m. Okay, only to show that it's possible to start and stop the charging of a Wallbox. Like here, I have installed Terra AC Wallbox. My car is connected, and I would like to start here via control element the charging of the car and stop, and to change here also, for example, the maximum current. Yeah, do not forget, we have to send here our Modbus commands, converted. So we have to send a 0 to start and a 1 to stop, and it must be, yeah, here a data point type 2 byte unsigned 0.x. And the current between 0 and 16 amps. So, and I have here a B23 meter with 3 phase, L1, L2, L3, here with some load, and also a B21 meter. This is what I would like to show you now practical. I hope you have 5 minutes time and you can still follow me. So here I have prepared the ETS project. You see the Terra AC Wallbox. You see here my B23 meter, my B21 meter with the imported energies. Exactly what I have done some minutes before. I have here entered object name, data point type, and so on. So then I have here also a link. Sorry, I have here linked then the group addresses. Yeah, you see here Modbus group objects. You see the group objects with the link group addresses. The device is downloaded, so I go immediately here to the group monitor. I start here recording. So what I can do, for example, I can at first I make here a restart of the device. Yeah, then he will send all the values. Okay, you see here I make a restart, and after the restart he sends all available values at the beginning. After download, or when you make a manual restart, you see here the in operation. You see here the value, the maximum for my Terra AC Wallbox. You see, for example, the maximum current at the moment, the maximum charging current. You see here the voltage between phase L1, L2, L3. You see the power is 0 because at the moment the device is ready for charging. Good, and I would like to start here the charging. Just at first, let me clear here the group monitor, and I send a command here from my control element, and I start now charging my car. So I press here one button. So then you will see he sent now a telegram with the value 0. So, and then we have to wait 2, 3, 4 seconds. And then he starts charging. You see here the current 10 amps because the maximum is 12. You see here still the voltage. You see here the power at the moment 2400 watts. My car is a hybrid, and the hybrid can be loaded only with one phase, with maximum 16 amps. So it's not a pure electrical car which can be charged via 3 phases. No. And then you see here the active energy 11 watt hours, and then it will also here increase 21 watt hours and so on. What is also possible to change the maximum current. You see at the moment the maximum current here is 12 amps, and via KNX Telegram I can change it, I can reduce it. You see I have now a current of 10 amps and a power here of 2400 watt. And now via another control element I set here a new, oh no, this was the wrong button, sorry, this one I sent here a value of 8 amps. Then he confirms, and you will see he reduced now the current here less than 8 amps, for example here to 6.6, and reduce also here my power. So depending on the available energy, I can reduce here the current and the power by sending a KNX telegram. Good. Or for example, I switch on here my B21 meter via KNX telegram, and then you will see here the current of my meter, B23 meter. I see here then the power, the total power, the power per phase L1. And when I switch on here another device, another channel, my phase L2, then you see here 67 total, and here 26 of my phase L2. Some words about troubleshooting if there are some problems in the installation. So at first check the cable, the wiring, the end-of-line resistor, such things, the parity. Remember, in all devices we must have the same speed, the same parity, start, stop bits, and so on. Unique addresses, and for more, please visit here the website of modbustools.com. You will find here also some diagnostic tools and so on. Good, and on KNX we have also here 4 let me say objects which can give the information about an error. It's a 1-bit information error alarm. It is 0 if communication to all meters is okay. If there's a problem to a register address or to a device, then it has the value 1, which can be used, for example, to trigger alarm message. And with the next group object, number 203, we get the address, the server address of a device with the problem. And with the next one, we get here the register address. Maybe when we have entered the wrong register address, which is not available in the meter. And get also here an error text. Error text here is defined in a different string, which is also specified in the Modbus maybe guidelines. Good. Okay. Here, for example, an error. I have disconnected here my meter number 1. Disconnected meter number 1. Then we get here 1-bit information alarm. We get in the object next one. We get the address of the meter number 1. We get here the register address. The first a register address he wants to read, but there is no communication. Then he shows me the information here, and here our string with the information about the error. So for really deep diagnostic, you can use here maybe a USB to RS485 converter, which is available by Amazon, costs about 20 euros. And with device, you can make a point-to-point connection to a meter, like here, ABB meter. You connect here the A and B and the ground, but remember, A and B must be swapped here by our ABB meter. And with additional software like here BaseBlock, which is free of charge available, you can see then here the communication. You can read out register addresses, you can write register addresses, you can test the communication, and so on. Good. Okay, then we come to some final slides. A small summary about the Modbus KNX Gateway. It allows to integrate Modbus devices into our KNX installation at the field level. Remember, we are not here on IP. We do it on Twisted Pair and Modbus RTU. We have a bidirectional communication of 100 data point types, status and commands. The device needs maximum 22 milliamps. So if you calculate how many devices per line, please be careful, count it as 2 devices. We have our device configuration app. For maybe easy configuration, we can use our mapping, we can create own mappings. So then let's come to my final slides. You will find all information about the Modbus Gateway on our website, abb.com/knx. Go to products, downloads, system infrastructure and interfacing, gateways, and there is the Modbus RTU gateway with the ETS application, DCA, product manual, and so on. So then we have also some product microsites. Microsites are special websites for a product or for maybe a system. Like, for example, here we have it for Modbus RTU, or for our energy meters, charging solution, and the Wallbox. And you can find there some main features, product overview, service and tools, downloads, and so on. These are here so special microsites. So now what is new? Not really new, but here we use it especially for this device, is also called 2D code. So the device has a 2D code on the housing and the packaging, and when you scan this 2D code, then you will forward it here to the product page. And we use it also for traceability. So when you use an app, the so-called ABB Product Scanner app, which is also free of charge and available for Android and iOS, you get more information. So when you scan this QR code, you start the app, you click on scan, you scan here this 2D code on the device or on the packaging. And then what happens? A new window pops up here. It gives you here the order number, the ID number, and here also the unique KNX serial number, and possibility to click here on product page, and then you jump here to our product page of the gateway, where you can make also a download like the data sheet, downloads, and more information. And then you can click here on downloads, and then you get, for example, here the product manual or the installation operating instructions and so on. Good. Some words about our training material. Presentations, video tutorials, the webinar slides, and so on are in our training qualification database. You can have access via this link. It's free of charge. You need no registration, or go via abb.com/knx. And additionally on YouTube, we have also here then our videos available. We have come to the end of today's webinar about our new Modbus KNX Gateway. We look forward to seeing you again at the next webinar. You will receive the invitations again by email, and you can forward it also to your colleague, your friends. Feel free. Our webinars and trainings are open for everyone. I would like to say thank you for your participation. Goodbye and have a nice day.